Let's talk about the Maslow of row operations. So when you are using Gaussian elimination method, always try and achieve something like this, where you have the leading diagonals being 1, 1, 1, and you have 0, 0, 0 below the leading diagonals. So we are achieving this at the A part of the augmented matrix. So you first find your augmented matrix and try and achieve this. So in trying to achieve this, first ask yourself or make sure that is there any two rows I can swap to get 1 over here? Yeah. If there is two rows you can swap or subtract to get 1 over here, you do so. When you are done, try and achieve getting 0 over here. So if there are two rows you can combine to get 0 over here, try and do so. And the next step is to achieve this 0 over here. But in doing so, if there is a way you can break the elements here to get 1 easily, try and do so before achieving this 0. You see. But if there is no way, continue to getting this element becoming 0. Then the last thing is try and get this element 0. But always make sure that you have your leading diagonals finally as 1, 1, 1. Yeah. So when it comes to Gaussian elimination method, you realize that you can solve a particular question. Someone can solve the same question and you'll be getting different answers because you are using row operations and the approach varies. So I can decide to use two rows in achieving here getting 0. So maybe after getting here 1, I could try and use row 1 and row 2 to achieve here getting 0. Someone also can use row 2 and row 3 to try and achieve here getting 0. Yeah. So you realize in solving such questions we get varying answers. Yes. So let's go to Gauss-Jordan elimination method. So Gauss-Jordan elimination method, you always try to see whether you can get your 1 over here. When you are done, try and achieve you getting a 0 over here. The next step is to try and achieve getting a 0 over here. But if there is a way you can simply get a 1 over here, do so. And also, if there is a way that getting a positive 1 over here is difficult, you can swap what is over here with row 2. Try and do so before achieving 0. So after achieving this 0, you try and achieve this 0. When you are done, you try and achieve this 0. You try and achieve this 0. Then you try and achieve this 0. So you realize that there are some questions when you are solving, in trying to achieve maybe here getting 0, here getting 0, and here getting 0. You try and also achieve here getting 0 before you even get there. So when you are trying to achieve here getting 0 and you ended up getting here 0, so after this step getting 0, you are supposed to get here at 0. You already have here at 0, so you move on to getting here to 0 and getting here to 0. Now let's talk about rank of a matrix. So rank of a matrix, the first step is to try and make sure you get the elements over here becoming 1. Yeah. When you are done, try and get the elements over here becoming 0. The next step is to try and get the elements over here becoming 0. And try and get the elements here becoming 0. With man, we don't care about getting 1, 1, 1. No, that's not our primary goal. We only want to get 1 over here. And we don't care about all the leading diagonals becoming 1. The only thing we care about the leading diagonals becoming 1 is Gaussian elimination method, where you have 1, 1, 1. And all elements below the leading diagonals is 0. And Gauss-Jordan elimination method, where we have 1, 1, 1. All elements below the leading diagonal becoming 0. And the elements in the A part of the augmented matrix above the leading diagonals becoming 0. So that's what you need to know about row operation.